Highway Mapping Robot, the Mapmobile. This is the final project for the course ANPM 808X Software Development for Robotics. Overview of the project. A Turtlebot 2 is simulated that autonomously navigates around unknown roadways and maps it. A lane detection algorithm that is built on OpenCV is used for detection of lanes and follow it. A street sign detection is done using machine vision and machine learning algorithms. The overall system is implemented in ROS Kinetic and OpenCV 3.2, and Gazebo environment is used for simulation. The motivation of the project is that one of the most important things about autonomous vehicle is having accurate maps that the robot can use as a reference to make the system more robust. The Mapmobile performs generation of maps that can be used by autonomous vehicles, which saves the training time. Personnel background.
My name is Zachary Zimitz. I got my bachelor's degree in mechanical engineering from North Carolina State University, and my field of interest is autonomous vehicles.
And I'm Niket Shah. I got my bachelor's in electronics and telecommunications from Mumbai University, and my field of interest is vision and industrial automation. The system description. The activity diagram shows here that we first ascribe to the camera topic of the Turtlebot 2, and the data is sent to two topics. We look for the signs and we look for the lanes, and we publish the data. The data is subscribed by the navigator class, and the priority is first given to the sign data. If there is a sign and if the sign is large enough, that is, the sign is close by, the Turtlebot stops for 3 seconds, and if there is no sign, it just follows the lane and navigates around the roads. And if there is a turn, then the Turtlebot checks whether how much turn do we have to make, and it adjusts its angular velocity accordingly, and the PD controller helps it to follow the trajectory.
Alright, so on the right hand side you can see the commands necessary to clone and get the demo running on your computer. We skipped this part in the actual demonstration because it's kind of monotonous to watch someone type in commands over and over again, and we've only got 5 minutes for this presentation. But a couple things to note about running the simulation. First is that Gazebo will start in a pause state. This allows the time for everything to get initialized before the Turtlebot starts to move. The other thing, there will be 2 OpenCV windows that'll show the lane detection algorithm and the sign detection algorithm. And finally, once the RViz is open, you have to add a display for the map and subscribe to it in order to view it. And now we're going to go on and show you the demonstration. So there were a couple bugs in the software, but that just leaves us more room for future work. Firstly is we want to have an improved path planning algorithm. As you can see, when we run around the lane, it's a little jerky. As it loses one lane, it turned really hard to the right instead of kind of following a smooth path around the lane. So that could definitely be improved. We like to add in capabilities for more signs. We only had stop signs in our final world, but there was some work done with speed limit signs to adjust the speed of the Turtlebot. And finally, there are some false positives we're having depending on the lighting conditions. If it was dark out, or if they're in the darker areas of the map, the algorithm found more false positives of stop signs than we really would have liked. So that's definitely something that can be improved in the future. Thanks for watching the presentation.